Uh, okay, today is May 7th, and this is a course on the hydrogen technology. Now, you have this lecture note, and again, here are the table of content, starting with chapter 1, which introduced the hydrogen gas, global trend, and policies, and so on, and chapter 1, 2, 3, 4, 5, and 6, which was covered last week, hydrogen storages, covered basically in chapter 5 and chapter 6, hydrogen storages. Now, technically, once we have a hydrogen stored, the next step will be generate electricity from hydrogen. That's what the fuel cell does. So we like to overview the fuel cells, which is the most important component in fuel cell vehicle, like Nexo in Hyundai and Mirai in Toyota. So we review, and there are several different types of fuel cell, and efficiency and performance and application in transport and stationary power, challenge and future development. And chapter 8 is about the hydrogen combustion engine. Well, as you can see that using the hydrogen, we can directly generate the electricity, and then we use that electricity to run, say, electric motor. That's basically what it does, what's happening in hydrogen car. But in chapter 8, rather than generating electricity, we can use the hydrogen for the combustion system, internal combustion system, which mainly use the gasoline and etc. But rather than using gasoline, we can directly use a hydrogen gas. It is called hydrogen internal combustion engine, which is also very promising. And what would be the limitations of this hydrogen combustion engine? And then what is the bright side of this hydrogen combustion system? So we like to briefly review of chapter 7 and chapter 8, and then followed by the chapter 9, hydrogen in land mobility. We time to time already cover these topics. Fuel cell electric vehicles and trucks and buses and trend and infrastructure needs hydrogen motorcycles. So rather than just a passenger vehicle, we could apply hydrogen system to trucks and buses. Actually, this heavy truck is more demanded in hydrogen fuel cell systems. And also, this is a land mobility. And chapter 10, there could be a air and sea mobility. This is much demanded in future. Very futuristic topics: hydrogen drones, hydrogen ships, and eVTOL, electric vertical takeoff and landing, and aviations, hydrogen balloons, and there are some still a little bit of a technical barriers. So, but we engineers need to understand the potential applications of a hydrogen system to more in land mobility and air and sea mobility. And then hydrogen can be also used for the smart grid system. Smart grid means that we optimally control the electricity using some different types of a storage system for the given energy in from renewable energy or some other conventional energy or power in. So in this grid system, the energy storage can play the most important role. But importantly, we need to understand the concept of the grid system. And then these days, a lot of research is going on to efficiently control the energy and power, not to waste energy. And hydrogen storage can be one component for this smart grid system. And hydrogen microgrid. And the economics of hydrogen energy and environmental impact of hydrogen and future trend and hydrogen technology, and followed by the hydrogen beyond green strategic lifeline for South Korea, China, India, and Brazil. So technically, I believe this the topic we're gonna cover today, the fuel cell, electricity productions from hydrogen, the fuel cell is the one of the most important the component in using hydrogen as a fuel system. So I don't want to cover the detail about the chemical reactions and etc. We just understand the basic principle and operations and the so basically we're gonna go through some of the well-known YouTube, and we watch together, and then we gonna discuss together. Chapter 7 here, actually we list some key point: electricity production from hydrogen. As you can see here, oops, I'm sorry, I didn't share my. So chapter 7, electricity production from hydrogen. This is the topic we're gonna cover. So this chapter details the electricity production via fuel cells. Fuel cell, there can be several different types. And then with a different efficiency. Toyota Mirai has some fuel cell, which is the power of which is the 114 kilowatts, and some examples. And the cost is important. And the fuel cell overview. Basically, there will be a conversion of hydrogen actually combined with oxygens. Then these are turned into electricity and a little bit of heat and water. Water is output, and then here the H2 and O2, and so there are electrochemically there are some electrons comes out from this system. Actually, what's happening in the anode, they always even the battery or fuel cell, we always have an anode side and cathode side. So anode H2 is a split into 2H plus the 2 electrons, and conduct ions through the electrolyte. These 2 electrons these two H plus go through electrolyte through an electrolyte and go through a membrane and then recombine with O2 in the cathode side. Then water comes out, and this electron, two electron that go through some circuit and giving us the energy, electricity. So there could be some different types of PM and SOFC and AFC, but the PM is the most well-known type. Okay, well, there are some number which characterize the fuel cell of Toyota Mirai. And again, the Toyota Mirai and Hyundai Nexo are the two most well-known fuel cell. So there are some good reference. So PM, so a fuel cell, a proton, the H plus, proton exchanging membrane. So PM fuel cell operates not much high temperature, but proton conductive polymer membrane to shuttle H plus ions from anode to a cathode with a platinum catalyst. This is important, platinum catalyst. Without this, it's very difficult to split H2 into protons. This H2 needs to be accelerating the H2 oxidations, and the O2 and H2 giving us water. And always there is an efficiency, where the efficiency is current technology. The efficiency of current technology is about 50 to 60%, while the efficiency is reaching higher and higher, but this is a reality right now. And also, Hyundai has some fuel cell. Again, the driving range is important, about the 600 kilometer or 700 kilometer. That's the one. So yeah, some the numbers and explanations, and we need to understand the by going through some website and YouTube. So today, let's watch some of the video together, and then let's discuss. I collected some of the hydrogen fuel cell YouTube. Okay, well, there are already very good YouTube describing proton exchanging membrane, hydrogen fuel cell, electrochemical. Well, it's important to understand electrochemical device reactions. We mostly mechanical engineer. Now we need to be well trained, multidisciplinary, to understand a little bit about electro and a little bit about chemical. And then this is a critical to understand the all kinds of energies. Energy conversion is mainly through electrochemical reactions. It's like the battery. Battery is also an electrochemical device. Anyhow, that combines the hydrogen and oxygen to produce the electricity with the water and heat as a byproduct. As you can see, water and heat are byproduct. Well, water naturally comes from this reaction, and the heat as well. But the heat is always kind of unwanted byproducts, which will affect the efficiency. So anyhow, let's go through little by little and then discuss. We can turn the captions on. But this is a very short one. But we have many different types of video. As you can see that here is the H2 supply. And as I just mentioned that there's a catalyst, platinum, which is very expensive. And then there will be a proton exchange membrane, PM. And then there is also another catalyst. And the so H2 will split H plus and electron and goes like this. We watched this video several times, but the it's always we cannot emphasize enough how important to understand these systems. As you can see that hydrogen enters and is split, okay? This is split into protons and electrons. So these are the electrons in red color, and then a proton is blue. They are split, basically. That's what's happening in anode side. And then, well, for this separation, again, the catalyst plays the most important role. And there are a lot of researches going on to find what's effective catalyst instead of expensive, the platinum and so on. So once this one is separated, this will go through a proton exchange membrane, PEM. So actually, this is a H plus, and then there is oxygens. Oxygen is just from the air, so it costs nothing. So basically, the H plus and O2, and they combine. Okay, so what it does actually, the H2 supply hydrogen from a hydrogen tank and hydrogen supply and catalyst the split the electron and the proton. So electron now go through all the electricity and then giving us the energy. Now there and this as you can see, electron and travel, and there is some heat generated that's not avoidable. Again, affecting the efficiency, and then H2 finally will be a byproduct. H2 comes out. So we always need to visualize this one in mind, what's happening with the H2 in and H2O water comes out. This is the anode side and cathode side. Again, as you can see that this is the H plus proton travel and meet with the H2, giving us the water. And then, well, yeah, I'm repeating the behavior. Okay, so this is how the fuel cell work. Very short video, but please keep that in mind. And we need to visualize that. As you can see that to increase the energy density or energy or power, we need to increase this area. Okay, this area. So rather than making big, this surface area, we kind of stack this one. We put the stack again and stack again and so on. So rather than make a one big thin exchanger, we are developing multi-layered. So it's just a matter of the connecting electric or chemical channels. That is not the big problem. Again, the big problem is the efficiency and then how to handle this heat and so on. Okay. Well, this one video fully give us the overview, but let's keep watching the others, and which could be. Welcome to our video. Now, this one is a real application to a fuel cell. Rather than the overview of what's going on in fuel cell. Well, this is also very well-known video. We already watched that, but we need to repeatedly watch this video. So this is about 5 to 6 minutes. Let's watch together. The function of a hydrogen vehicle. Have you ever wondered what powers a hydrogen vehicle and how it differs from traditional gasoline cars? Well, in this video, we'll take a closer look at the different components that make up a hydrogen vehicle and how they work together to power the car. We will also discuss the benefits of hydrogen vehicles, such as their energy efficiency and environmental friendliness, as well as the problems that still need to be solved before they can be used widely. First, let's take a deeper look into the differences between hydrogen cars using electric motors and combustion engines. Both types of vehicles use hydrogen as fuel. The way they convert that fuel into power is different. A hydrogen car using an electric motor is known as a fuel cell electric vehicle, also called FCEV. In this type of vehicle, hydrogen gas is fed into the fuel cell stack, where it undergoes a chemical reaction with oxygen from the air to produce electricity. There are a few types of electric vehicle, also called FCEV. In this type of vehicle, hydrogen gas. Okay. As you can see that this container or tank contains hydrogen. Hydrogen gas is all we need. And the other component like the O2, oxygen can be from air. So we have a hydrogen stored in the tank. Now this is the fuel cell, which we just reviewed what's going on inside the fuel cell. Actually, the H2 goes in there, and then there are high O2, oxygen comes in together, and then there will be some waters comes out. And then the electricity will be generated, and which will be used to run the motor simply. It's fed into the fuel cell stack, where it undergoes a chemical reaction with oxygen in the air to produce electricity. There are a few types of fuel cell stacks. The most common ones are proton exchange membrane and solid oxide fuel cells. Proton exchange membrane fuel cells are typically used in cars because they can start up quickly and operate at low temperatures. Solid oxide fuel cells, on the other hand, are better suited for stationary power generation because they require high temperatures and operate efficiently. Fuel cell stack consists of multiple fuel cells which are stacked together. Now, this is the real stacked fuel cell. We just watch the one cell to understand what's going on, but this is a real one. So rather than large thin layer, we stack them and to have a space efficiency. Then the operation principle basically same as the one cell. This is just scales up to increase the power. Together to increase the amount of electricity produced. Each fuel cell contains an anode, cathode, and an electrolyte. And when hydrogen gas is introduced to the anode and oxygen is introduced to the cathode, a chemical reaction occurs, producing electricity. Electricity powers an electric motor that drives the car's wheels, with water being the only byproduct of the reaction.
Hydrogen car using a combustion engine is called a hydrogen internal combustion engine vehicle. In this type of vehicle, hydrogen gas is fed into an engine where it is mixed with air and ignited. The resulting explosion drives a piston, which turns a crankshaft and powers the car.
Okay, this is a different explanations. As I mentioned, this is the hydrogen combustion engine. So using the hydrogen as a fuel similar to a gasoline, because the hydrogen gas itself can be flammable, so we can explode, and this is just the internal combustion engine. So instead of using the gasoline, we can use the hydrogen. In this way, the most advantage is that we don't need any extra fuel cell system. We can use existing conventional combustion engine. But this combustion engine, in principle, very similar to a conventional one, but there is a little bit a minor modification. And this technology is really led by the Toyota. Toyota is developing this hydrogen combustion engine system.
However, hydrogen internal combustion engines emit pollutants such as nitrogen oxides and particulate matter, similar to gasoline-powered engines.
Oh, and this hydrogen combustion engine and produce byproduct, it generates not only water but the sort of particular, it says particular matter similar to gasoline powered. So that is
However,
the
fuel
bad
cell
side.
electric vehicles have an efficiency of 60%, which is 2 times higher than the efficiency of the combustion version. This means that fuel cell EVs require less hydrogen to travel the same distance, making them more cost-effective in the long run. Another important part of the SEV is the electric motor. This is what converts the electricity produced by the fuel cell stack into mechanical energy that moves the car. There are 2 main types of electric motors used in fuel cell vehicles: the AC synchronous motor and the DC brushless motor. The main difference between these 2 types of motors is in the way they operate. The AC synchronous motor uses a set of magnets to create a rotating magnetic field that interacts with a set of coils to generate torque and turn the motor. The DC brushless motor, on the other hand, uses electronic commutation to switch the direction of the magnetic field and keep the motor turning. This makes the DC brushless motor more efficient than the AC synchronous motor, but also more complex to design and manufacture. Next, we have the hydrogen storage tank. There are 2 main types of hydrogen storage tanks: compressed gas tanks and cryogenic liquid tanks. Compressed gas tanks are made of high-strength materials and are pressurized to store hydrogen gas. Cryogenic liquid tanks, on the other hand, store hydrogen as a liquid at extremely low temperatures. Further components of a hydrogen vehicle are the power electronics, which manage the flow of electricity between the fuel cell stack and the electric motor. These electronics include inverters, converters, and other devices that control the voltage and current to ensure that the electric motor receives the right amount of power to operate efficiently. In addition, there is a cooling system that helps regulate the temperature of the fuel cell stack and other components. The cooling system uses a combination of air and water to maintain a safe operating temperature and prevent overheating. Hydrogen vehicles also have a battery pack, which is used to store excess energy produced by the fuel cell stack. This excess energy can be used to power the electric motor during periods of high demand or to start the car in cold weather when the fuel cell stack may need additional time to warm up. Finally, the hydrogen vehicle has a number of safety features, including pressure relief devices and sensors that detect leaks or other potential hazards. Now let's take a closer look at how the different parts of the hydrogen vehicle work together to power the car. When the driver presses the accelerator pedal, the hydrogen gas is released from the tank and flows through a regulator valve, which controls the amount of hydrogen that is supplied to the fuel cell stack. In the fuel cell stack, the hydrogen gas is combined with oxygen from the air to produce electricity through a chemical reaction. The chemical reaction occurs at the anode of the fuel cell, where hydrogen molecules are split into positively charged hydrogen ions and negatively charged electrons. The electricity generated from this chemical reaction is then sent to the electric motor, which converts the electricity into mechanical energy that powers the car's wheels. As the car moves, the only emission produced by the SEV, as we said before, is water vapor, which is released from the tailpipe. This means that hydrogen-powered cars are not only more energy efficient and environmentally friendly than traditional gasoline cars, but they are also much quieter and produce less vibration. One of the main concerns about hydrogen-powered vehicles is the cost of hydrogen fuel. Currently, producing hydrogen is more expensive than producing gasoline and diesel fuel. However, the cost of hydrogen is expected to decrease as more production facilities are built and economies of scale are achieved. There are also three types of hydrogen, which can affect the cost. Green hydrogen is produced using renewable energy sources, such as solar power, and is considered the most environmentally friendly choice. Blue hydrogen is produced using fossil fuels, with carbon emissions captured and stored, making it a cleaner alternative. Gray hydrogen is produced from natural gas through a process called steam methane reforming, results in carbon dioxide emissions being released into the atmosphere. It is currently the most common method of hydrogen production and is also less expensive than green hydrogen. In conclusion, hydrogen vehicles are a promising alternative to traditional gasoline-powered cars. Fuel cell stack, hydrogen storage tank, and electric motor work together to produce an energy-efficient and environmentally friendly mode of transportation. However, as we continue to move towards more sustainable and eco-friendly forms of transportation, hydrogen vehicles present a promising alternative that can help reduce our carbon footprint and create a more sustainable future. We really appreciate your support of our channel, and thank you.
Yes. Well, together with this fuel cell, which generates electricity, now the next component is a motor. Motor is the real actuator to run the rotate the wheels and move the vehicles is moves. Now the one of the main reasons why the EV electric vehicle get so popular is not just because of a battery technology, but also this the motor technology. So it is very critical to understand the how, I mean, not in detail, but the basically how this motor system works. And here, this video introduced a little bit about the BLDC and also there is some other synchronous motor. Okay, I will just let's go through.
The DC brushless motor, on the other hand, uses a
this is a BLDC motor in short.
Electronic commutation to switch the direction of the magnetic turning. This makes the DC brushless motor more efficient than the AC synchronous and also more complex.
Now, AC synchronous motor.
That's the design and manufacture. Next, we have a hydrogen storage tank. There are two types of motors in the way they operate. The AC synchronous motor uses a set of magnets to create a rotating magnetic field.
Now this
the AC
synchronous motor. Actually, this is a rotor and this is a stationary part. Mostly consists of the coils here. So basically, this one, the most key point is the rotating part. All consists of all the permanent magnet. You know, recently the permanent magnet technology, material-wise, and the is improved a lot. And one issue, still a big issue, is that this heavy magnet have to rotate very high speed, like the 2000 and 3000. And imagine this heavy magnet is rotating. What will happen? Well, there will be a lot of high centrifugal forces will be exerted to this magnet. And then outside, as you can see, we have a stationary coils. So to work as a design, one most critical point is that to keep this heavy magnet to be in place. So that's that is what we need. So we mechanical engineer need to develop how to keep this heavy magnet to be in place. Well, to do so, there are a lot of research and development. One of them is we put the wrap this permanent magnet using the CFRP, carbon fiber reinforced plastic, which is very light and very stiff. So we wrap around, and there are very tiny gap there between the stationary and rotating parts, and say order of a millimeter. But imagine how heavy and how fast they rotate. So that is the one of the key technology we can design and we can develop from a mechanical engineering side.
This motor uses a set of magnets to create a rotating magnetic field that interacts with a set of coils to generate torque and turn the motor. The DC brushless motor, on the other hand, uses electronic computation.
Yes, this BC brushless BLDC motor effect, the efficiency wise could be higher, but this synchronous motor is still efficiency is over 90%, which is really a breakthrough, which makes the possible of these electric vehicles together with the battery things. Now, even for the hydrogen vehicles, basically we generate electricity from a fuel cell. We still need to understand, we still need to use this electric motor. Yeah, we pay attention to the technology to this electric motor. So anyhow, what they are saying is that they are getting the hydrogen from hydrogen tank, and then a fuel cell and electricity go into the motor. What's that? That's what I and then as we already discussed that instead of a high pressure gas, they could use the very low temperature liquid hydrogen. But as we know already, this to keep the hydrogen as a liquid, the temperature has to be really low, minus 253. That requires a lot of energy.
Temperatures. Further components of a hydrogen vehicle are the power electronics, which manage the flow of electricity between the fuel cell stack and the electric motor. These electronics include inverters, converters, and other devices that control the voltage and current to ensure that the electric motor receives the right amount of power to operate efficiently. In addition, there is a cooling system that helps regulate the temperature of the fuel cell stack and other components. The cooling system uses a combination of air and water to maintain a safe.
The cooling system is the one of the key, in addition to a main system, operation of a main system, like a fuel cell. The fuel cell, we got the lot of course, the electricity back, but there could be a lot of heat. So we need a heat management systems, water cooling system, or just the free air cooling system as well.
Operating temperature and prevent overheating. Hydrogen vehicles also have a battery pack, which is used to store excess energy for use by the fuel cell.
Oh, don't get confused. Even hydrogen car, we need a little bit of a backup fuels. The battery. Not as big as the real electric vehicle, but hydrogen car also need a little bit of the battery, which can play an important role.
Stack. This excess energy can be used to power the electric motor during periods of high demand, or to start the car in cold weather when the fuel cell stack may need additional time to warm up. Finally, the hydrogen vehicle has a number of safety features, including pressure relief devices and sensors that detect leaks or other potential hazards. Now let's take a closer look at how the different parts of the hydrogen vehicle work together to power the car. When the driver presses the accelerator pedal, the hydrogen gas is released from the tank and flows through a regulator valve, which controls the amount of hydrogen that is supplied to the fuel cell stack. In the fuel cell stack, the hydrogen gas is combined with oxygen from the air to produce electricity through a chemical reaction. The chemical reaction occurs at the anode of the fuel cell. Hydrogen molecules are split into positively charged hydrogen ions and negatively charged electrons. The electricity generated from this chemical reaction is then sent to the electric motor, which converts the electricity into mechanical energy that powers the car's wheels. As the car moves, the only emission produced by the SCV, as we said before, is water vapor, which is released from the tailpipe. This means that hydrogen-powered cars are not only more energy efficient and environmentally friendly than traditional gasoline cars, but they are also much quieter and produce less vibration. One of the main concerns about hydrogen-powered vehicles is the cost of hydrogen fuel. Currently, producing hydrogen is more expensive than producing gasoline or diesel fuel. However, the cost of hydrogen is expected to decrease as more production facilities are built and economies of scale are achieved. There are also three types of hydrogen, which can affect the cost. Green hydrogen is produced using renewable energy sources, such as solar power, and is considered the most environmentally friendly choice. Blue hydrogen is produced using fossil fuels, but the carbon emissions are captured and stored, making it a cleaner alternative. Gray hydrogen is produced from natural gas through a process called steam methane reforming, which results in carbon dioxide emissions being released into the atmosphere. It is currently the most common method of hydrogen production and is also less expensive than green hydrogen. In conclusion, hydrogen vehicles are a promising alternative to traditional gasoline-powered cars. The fuel cell stack, hydrogen storage tank, and electric motor work together to produce an energy-efficient and environmentally friendly mode of transportation. However, as we continue to move towards more sustainable and eco-friendly forms of transportation, hydrogen vehicles present a promising alternative that can help reduce our carbon footprint and create a more sustainable future. We really appreciate your support of our channel and is also listening.
This slide shows that how the hydrogen gas can be generated, depending on the shows the different method. Actually, this was covered early stage of our class. Basically green, this electricity comes from the renewable energy like a solar cell and the wind turbine blade, and also blue and gray. Blue, basically it comes from the energy sources of natural gas and fossil fuel cells, but this CO2 byproduct is a CO2 rather than O2 in green. Then this CO2 is captured, carbon captured, and gray. Unfortunately, we just get a H2, and no actions are placed to this CO2. So this is not so the environmental friendly. So basically, there are another color like the white and the gold. And the pink, the pink is the electricity generated from the nuclear power. There are so many colors, but basically it's important to understand these three most important things. And so through this course, we like to get reminded of all the technology related to hydrogen. So this hydrogen technology is not stands alone. They place all together.
Expensive and green hydrogen. In conclusion, hydrogen vehicles are a promise during the video and subscribing to our channel.
Okay, so through this video, we got an overview of the not only fuel cell but also conversion and storage, and also how to generate hydrogen from renewable energy and so on. Okay, well, same topics, but a little bit different overview and different view. Let's watch the another one. Well, okay, this is the how does hydrogen fuel cell works. By now, you got more idea, but this explain a little bit different way. See, you can find a lot of different sources explaining about how this fuel cell works. Basically the PEM, but is quite worthwhile to watch different videos and see this.
Can be used for a wide range of applications, like transportation, material handling, backup power applications, etc. The conventional combustion-based technologies presently used in vehicles and power plants. It is an opportunity for the fuel cell to provide its benefits. Hydrogen is used to power the fuel cell electric vehicles FCEVs. It exerts more efficiency over conventional engine vehicle as it produces no tailpipe emissions, but only emits warm air and water vapor. Let's learn how a hydrogen fuel cell works. Do you know how a battery works? Yes, the fuel cells work like batteries, but they do not run down or need recharging. They can produce electricity constantly. Fuel cells operate at higher efficiencies than a combustion engines, and they convert the chemical energy from the fuel to electrical energy. A fuel cell is composed of two plates separated by an electrolyte membrane. One plate is called anode and the other is cathode. Hydrogen is passed through the anode while oxygen is passed through the cathode.
Yeah, while sometimes it's a confusing explanation, but again, the H2 comes into anode side. Okay, this is the cathode side, where the H2, H plus and O2 combine and giving us the water. Okay, so this is the anode and cathode.
Cathode. At the anode, hydrogen molecules are split into electrons and protons by a catalyst. The positive particle of hydrogen can pass through the membrane, but the negative particle cannot pass through it. However, atoms need an equalizing charge, and to achieve this, electron must change the path. At that time, the electrons are forced through a circuit and generates electric current and heat. The end product of this reaction is water, H2O. At the cathode, the hydrogen protons, electrons, and oxygen combine to produce water molecules. Due to the lack of moving parts, the cells are highly reliable and its operation is silent. The hydrogen fuel cell is useful in the automobile industry also. Currently, there are several companies around the world working on the development of hydrogen cars. To learn more about the hydrogen fuel cell car, check out our next video. Friends, please share this video.
Okay, again, it's very short one, but a little bit different way of explanation. Let's go to another one. Well, it is 4 o'clock. Okay, let's have about a 10-minute break. I will pause it here and let's get back in 10 minutes. Thank you.
Hydrogen fuel. Engines.
Well, next video we like to watch is the this is from a YouTube channel explaining a lot of interesting engineering behavior.
Revolutionary engineering breakthrough. Hydrogen cars are very similar in many respects to that.
Again, we are watching the video, almost the same, covering same subject, but a little bit of a different way of explanations. So the reason why we like to watch many different the video on the same subject is that we like to first we like to better understand what will be the common what is the main common interesting point rather than led by the one particular opinion. We like to have a very different opinions and then helping us better understand the true real interesting
demonstration that both are ultimately driven by electric motors. However, one of the main differences is that an EV car gets its fuel from the grid.
Now, as you can see, that electric motor, that electricity comes from the hydrogen, and then electric motor comes from the battery things. But anyhow,
which stores it in a sequence of lithium-ion batteries. Hydrogen completes its fuel to what's known as the fuel cell. It's important to note that hydrogen itself is not a true fuel, rather a carrier of energy.
Okay, well, this concept was discussed very early class of this course. Hydrogen is not a true fuel, and instead it carries the energy. So we often call hydrogen as an energy carrier made from other process. Why we better need to clearly understand this point. So hydrogen, hydrogen has a high potential energy, I would say. So to be an energy carrier, we have to put the energy into the, for example, the water, we split and get the H2. Then to do so, we put a lot of energy. So in terms of energy level, the H2 gets a high energy, and then H2 now get released into water. Then we can get the energy back. I hope that. Okay, I'm gonna go through that. I hope that you understand this slide explaining. This is I would say the green hydrogen starting from H2, very low potential energy, and then there is we add energy E, and then we split H2 into H2 and O2. So as you can see that H2, how much high energy it has. So what it says right now is that H2 is rather than just the fuel, H2 is the energy carrier. So it can be distributed, it can be stored. It's similar to carry the energies. And then whenever we need energy back, so we add O2, H2 plus O2, and by product we back to the H2O, but there will be energy out. So the power to gas, this diagram shows the concept of the energy carrier, H2. Okay, let's get back. So hydrogen is not a true fuel system. Instead, it carries energy made from other process.
That is made from other processes. Because the vast majority of hydrogen on Earth is trapped in water, processes such as chemical formation and electrolysis are needed to separate out the hydrogen. Hydrogen has an extremely low density in both gas and liquid states, and as such, it must first be compressed to up to 700 times atmospheric pressure.
And now it emphasized that this hydrogen itself as which can be generated from the electrolysis and the electrolyzer, then H2 itself has a very low density. It takes too much volume to carry. So we have to have a high pressure to increase the density. This is the same topic we've been discussing so many times. So 700 bar is the common pressure, so that this can be well carried by the one vehicle, and then driving range can be up to 700 kilometers.
Adequate fuel density within the vehicle. Furthermore, hydrogen is extremely flammable and explosive.
Yeah, there are two keywords. The characteristics of a hydrogen gas is very flammable and explosive. Well, explosive, what does it mean? Explosive mainly comes from the high pressure tank, not just the hydrogen itself. Now, hydrogen itself is flammable. Flammable is very quickly react to high fire. So flammable and explosive. That's why we need to develop further technology to carry in a safe way.
The storage tank must be stored and built to high tolerances to prevent leakage. The hydrogen is fed from its storage tank to the fuel cell, where an electrochemical reaction known as reverse electrolysis takes place. The fuel cell is made up of three parts. Similar to a battery, it has a positively charged terminal, the anode, a negatively charged terminal, the cathode, and a separating membrane, the electrolyte, which is sandwiched in between. This setup is typically known as a polymer exchange membrane. At the anode, a catalyst, usually platinum, oxidizes the hydrogen, turning it into positively charged hydrogen ions and electrons. This reaction releases heat. The polymer membrane is designed to allow the positive hydrogen ions to pass through the membrane and into the cathode, leaving the electrons behind, thereby giving the anode a negative charge. This voltage difference between the terminals causes the electrons to follow an external circuit from anode to cathode, which creates an electric current. The DC current from this process must then be converted to AC by means of an inverter to power the electric motor. At the cathode, the hydrogen ions rejoin with the electrons, and together they combine with oxygen from the air, which creates a chemical reaction that produces water. This is the only byproduct from the process. The water is released as either steam or vapor to the vehicle's exhaust. One fuel cell would not nearly provide enough electricity to power the vehicle. Therefore, multiple fuel cells are stacked in series with each other to account for this. Some hydrogen vehicles, such as the Toyota Mirai, also have an onboard battery which can store excess or one fuel cell.
There are several, YouTube and pictures, and they explain how this system works. But this very short video showing this figure, I think this is the most clear way of introducing fuel cell. This is the hydrogen tank, and this is the anode and cathode and the membrane system. And then this H plus proton travel. And then there is oxygens and exhaust, as water is the only byproduct. And now this one go into an inverter, is a motor system. Actually, they convert to DC. This is always a DC. Now we have an inverter, converting DC to an AC. Now that's AC synchronous motor will run. So this is the giving us the all about the hydrogen car. So again, we need to keep thinking and visualizing, and keep asking and keep getting answers, and train yourself, or try to help yourself get familiar with this fuel cell system. And then engineer will have a chance to work on to say develop hydrogen tank or develop the membrane PM, or working on the AC/DC inverter or AC motor, and many things. So
byproduct from the process. The water is released as either steam or vapor with exhaust. One fuel cell would not nearly provide enough electricity to power the vehicle. Therefore, multiple fuel cells are stacked in series with each other to account for this. Some hydrogen vehicles, such as the Toyota Mirai, also have an onboard battery which can store excess or reclaimed electricity from regenerative braking to further the vehicle's total range. The exciting thing about hydrogen cars is the range that they can potentially deliver, which comes quite close to that of a petrol vehicle. For example, the Toyota Mirai has a total range of 500 kilometers. Electric vehicle producers claim that they can match this, however, that is largely dependent on how much energy is used for other onboard processes. Hydrogen cars can be refueled in under 5 minutes, which is also a big bonus, as it is not such a giant leap from modern gasoline vehicles. Hydrogen also produces very few byproducts during use and can be considered an environmentally friendly fuel, with one important caveat. The electrolysis used to make hydrogen must be done using clean, renewable energy. Hydrogen cars are similar to EVs in this respect. Now for the bad news. Fuel cell technology, in spite of all of its promising benefits, is less than half as efficient as an electric vehicle when you take into account the entire energy claim of the vehicle.
now this is the one, the most important point we have to understand. The current, status of technology of fuel cell. Always the energy conversion is related to efficiency. How efficient we convert energy. So this left-hand side is the hydrogen. This is the electric vehicle. Electric vehicle, they are purely using the battery things, and the hydrogen is using the hydrogen gas, and then the fuel cell generate electricity and so on. So let's see what they are saying. As you can see, it is much less the efficiency.
Electrolysis, which is an inherently inefficient process, is needed to isolate hydrogen. Then must be compressed, transported, stored, finally converted back into electricity to reverse electrolysis. With each of these processes comes an input and therefore an overall loss of efficiency. It is possible that hydrogen could be produced and stored at the point of refueling so that the transport element could be removed, yet there are still significant challenges remaining. The obvious question is, why wouldn't you just go down the more straightforward route and store that initial electricity in batteries so that the transport element could be removed, yet there are still significant challenges remaining. Obvious.
Okay, well, I would like to repeat what he says. This is the efficiency of a fuel cell. Let's say 100% means that we have energy from a renewable source or any other source. Now, to generate hydrogen, we use the electrolysis. So there is an efficiency to generate the hydrogen. Now, if we have a hydrogen, we need to compress to increase the 700 bar, whatever. So there is the compression. We need some energy in. And then once that's stored into a hydrogen tank, now fed into a fuel cell, which will be also have some efficiency. That is about this much efficiency will decrease. And then this hydrogen, the electricity from this fuel cell and driving the motor. And there is another motor efficiency and AC/DC conversion. So as you can see, as a result of starting from 100% of energy, now it's reduced to about the 25% of energy back. This is the only energy we are using to run the electric fuel cell vehicles, unfortunately. And as earlier explained, they explained that our hydrogen is very clean, and just water comes out, and also a very quick charge, like the 5 minutes charging, and then giving us 500 kilometer plus range, which is almost as good as the conventional one. But again, it can be very clean, environmental friendly, because there's no CO2 generate, nothing but just water. But the conventional electric vehicle, there is electric vehicle losses, like here, motor and this motor, electric charging. Well, charging, what does it mean? Charging, since we are using the lithium battery, the battery is starting from energy in the lithium battery, we have some efficiency as well, so meaning there are some loss. So and then inverts and converter. So we lose about the 30% or 40% energy. So as a result, if you compare this net energy back, as you can see, electric vehicle is a much more efficient than a fuel cell.
This question is, why wouldn't you just go straightforwardly store that initial electricity batteries they would use for electric vehicle? The infrastructure for hydrogen is also much less developed than that of electric and gasoline, and it would take many years for the industry to catch up. However, emerging companies such as Nikola plan to develop hydrogen transport networks for their fuel cell trucks and one of the most important supply routes in the United States. Over time, this may help to scale their operations to greater customer base. The high cost of buying a hydrogen car today is still unattractive for most people, where an equivalent EV can be picked up at almost half the price. The reason behind this is the associated cost with platinum, which is used as catalyst in fuel cells. Hydrogen fuel is also expensive and comes at a much higher price per kilometer than both gasoline and EVs. In spite of all of its flaws, perhaps hydrogen does have a future in larger modes of transport, where its counterpart is limited by the weight of its bulky lithium-ion batteries. Or perhaps it is just an expensive distraction where more brain power could be channeled into refining EVs or developing more efficient technologies. Nobody is certain what the future holds with all of the growing possibilities in this industry. Petroleum will undoubtedly play a much smaller part in our daily lives, and the sooner that we embrace a world powered by these alternative clean energy technologies, the better. If you enjoyed the video and would like to learn more about some of the world's most forward-thinking innovative solutions, consider subscribing.
Okay, well, again, as I mentioned, I liked this video. It touched all kinds of aspects of the hydrogen vehicles and compare with electric, the vehicles. And we need to clarify the efficiency of the hydrogen car compared with the electric vehicles. And then this needs to be well understood. To clarify the problem is the starting point of solving the problems. We cannot avoid this fact. So again, it's very important to understand the why there is some barrier we have to overcome. Well, even as you know, even with this very inefficient way of energy conversions in the hydrogen compared to electric car, but electric car, for example, there is a still issue of the slow charging, even though there are recent development of quick charging, like the 10-minute or 1 hour charging. But that cause another risk of a fire, and also recycling of a battery is a big issue, and then rare material such as the nickel, chrome, and things is a big increase the risk. Of course, there are a lot of different technology other than lithium-ion battery, like sodium, like the so many different technology is coming out to solve the problem associated with the battery things. And now again back to hydrogen electrolysis. That is the efficiency is this much efficiency is wasted in the electrolysis procedures. So we have to develop the electrolysis. I mean, this is starting from a green hydrogen, where the energy or hydrogen is generated from electrolysis systems. Actually, the energy is the cost of energy is nothing, zero, because all energies comes from the renewable sun and wind. Now compression we have to develop, and fuel cell. This is the as we watch that we now reduce the cost of this fuel cell. Not only the efficiency, always the issue is the efficiency and cost. Well, this is not only high cost, I mean, not only high bad efficiency, but also high cost. So we have to put our effort to increase the efficiency and then lower the cost and motor efficiency and so on. But once I believe that all these kind of technical barrier can be solved, but which will take time, and all we need to do is to reduce the time and also infrastructures of a charging system. Well, again, these days is a really transition period for us to changing from a conventional petroleum-based energy to electric. Now, electric, one of them is the hydrogen together with electric vehicles. Okay, so okay. Another video is from yeah, I mean this one we don't need it. We just skip. So this one we don't need it. Now next one is the hydrogen combustion, which this is a very promising engine system. See, the hydrogen can be used not just for the not just for the fuel cell, but the can be used for the yeah, here the making hydrogen. No, this one. Let's see. Let's watch this video showing that hydrogen combustion system. What does it mean, hydrogen combustion? Well, the well, rather than this one, I like to go through more. Okay, well, this is very lengthy. The hydrogen combustion system, and there is a well, I don't want to go in detail, but we need to understand the what kind of technology.
Large vehicles and such large trucks and everything.
So, okay, this is a webinar covering the hydrogen combustion system. Well, I'd like to emphasize that there are a lot of activities going on to use the hydrogen as a hydrogen combustion as I mentioned, can be the hydrogen combustions. Okay, well, it covers a lot of details, the business aspects and the challenge and opportunity moving toward the net zero in here. And again, as we just reviewed the problems associated with the fuel cell, now how to get rid of a fuel cell? Well, we could use just the combustion engines, and that can be one way. Okay, sorry, I like to.
And Toyota saved the combustion engine. They're one of very few companies to develop a liquid hydrogen engine. That means all the noise and excitement of a combustion engine, yet almost no carbon emissions. It's mostly just water coming out of the exhaust. How does it work? Liquid hydrogen is stored in a tank at negative 253 degrees Celsius. Using a liquid is super beneficial because it means you can store about 75% more hydrogen in the same space versus a compressed gas. That liquid hydrogen is pumped into a vaporizer, turning it into a gas, where it eventually is pumped all the way to the engine cylinders, injected in and operating much like a gasoline engine would. That all sounds lovely, right? And it is technically possible, but some huge challenges will likely never see this in production parts. Why not? If only there was a video deep diving into the details. Oh well. Next,
Okay, well, it doesn't. This is just a short video. I'd like to say the Toyota and the hydrogen. Oops, sorry. Hydrogen combustion engine system. Again, Toyota is exploring, Toyota is leading this technology, exploring hydrogen combustion engine, okay? It's just the combustion engine, but they're using the hydrogen as a fuel system. So it can be very, simple. We don't need a fuel cell. We don't need a other, the systems like the battery. We don't need that. We just need an engine and hydrogen. Of course, the hydrogen needs to be stored in the hydrogen tank as a potential path toward a zero emissions, leveraging existing internal combustion engine. The point is that this combustion engine is very similar to an existing internal combustion engine, and they're offering quick fueling. And this approach involves modifying the conventional engine to run on the hydrogen instead of a gasoline, producing water as a byproduct, as a metal. So elaboration, more detail, multiple paths to zero emissions, hydrogen combustion as a solution, the prototype and benefit of the hydrogen combustion, and performance and efficiency, and customer choice. So the Toyota, Toyota prototype Corolla Cross hydrogen concept. Well, there are still a lot of the fake news. Okay, you don't get don't be misled by this all the news about the is Toyota making a hydrogen combustion engine? Yes, Toyota is currently developing. I believe this one. I really big supporter of this technology. Well, there are things we need to understand that. Okay. Now let's go to a little bit of videos. Okay, this is the one video. But honestly, I like to say how much the true we don't know yet. But there is certainly the effort by the Toyota developing this hydrogen combustion engine. Let's see what they say.
What you have learned in order to grow and improve for. Never been more true in our industry than today. I believe automobile industry at that line. The same level of disruption as when we moved from horses to cars.
Japan has become a technological prodigy in the past few years, introducing numerous new technologies that are shaping the future of the transportation industry. However, Japan's Prime Minister recently announced a new technology that will certainly be the revolutionary benchmark for the entire industry. This will seriously jeopardize EV's current popularity on the market. Join us and buckle up for a new way of thinking as we discover how Japan will redefine how we think about transportation. Of course, the Prime Minister is talking about Toyota, which has been experiencing a brand renaissance over the past few months. The company, which has always been one of the most popular car manufacturers globally, has extensively modified and updated its entire range of vehicles and options to significantly boost its brand image and rival other, much younger and quirkier brands, notably Tesla. Toyota's uninspired brand image stems from the actions of its former CEO, Akio Toyoda. While a capable leader, Toyota considerably stifled Toyota's potential by prioritizing reliability over vehicle design, quality, enjoyment, and most critically, innovation. This company's strategy made sense 20 years ago. However, in the current market, remaining conservative would essentially lead to Toyota's inevitable demise. That is why Toyota stepped down in favor of Koji Sato, the former president of Lexus and Gazoo Racing, Toyota's motorsport division. Who do you prefer, Koji Sato or Akio Toyoda? Be sure to let us know in the comments section below. Sato has done wonders for the car company, as his insistence on modernizing the entire range of vehicles and offering new and never-before-seen features on vehicles allowed Toyota to once jump to the top of the pack. And thanks to this all-new company strategy, Sato has recently announced a completely new engine that was pioneered by Toyota. So let's answer the question, what is this all-new engine type? The all-new engine type is actually a hydrogen-powered engine. Completely new engine that was pioneered by Toyota. So let's answer the question, what is this all-new engine type? The all-new engine type is actually a...
Well, as you can see from this simple visualizations, all you need is the hydrogen and engine. Engine is similar to a conventional combustion engine. So imagine that this is just fuel and this is the engine. That's all you need. We don't need a fuel cell to generate the electricity. We don't need any motor. We just use the conventional automotive technology. So this can they are saying that this can be really revolutionizing the technology toward the hydrogen society. Well, of course, to generate hydrogen from electricity, we still need those procedures like electrolyzer, electrolysis to get the hydrogen. But this hydrogen fuel cell, the system is much simpler.
Hydrogen-powered engine. However, we're not referring to FCEVs like the Toyota Mirai, or EVs that use hydrogen fuel cells. No, the engine we're discussing is an internal combustion engine that utilizes hydrogen as fuel. This is big news, as it will allow Toyota to achieve its goal of zero emissions and, in the long term, become the cleanest car manufacturer in the world. As we all know, EVs and FCEVs require a lithium-ion battery pack, which requires huge quantities of lithium to be mined. Lithium is extremely expensive, and mining it is a very dirty business. Unfortunately, many car manufacturers have been searching for a completely new battery component that will replace lithium to no avail, as these other battery types are far less efficient than lithium-ion ones. Oh, and let's not forget that Toyota's own EV, the BZ4X, isn't selling very well. Until recently, Toyota didn't want to enter the EV segment at all, giving its competitors a head start on conquering the market. Additionally, Despite all their technological advancements, EVs remain impractical for many individuals, as their maximum range often falls short, particularly when considering the very long charging times. This is why Toyota is set on finding an alternative to electric vehicles in general, and going the way of hydrogen, which they already explored with the first and second generation Toyota Mirai, was most definitely the way to go. Hydrogen is the most abundant element in the entire universe, and using it instead of anything else, especially fossil fuels and lithium, would be one of the best ecological and economic decisions ever. Seriously, cars would be cheaper to buy than regular petrol-powered vehicles, and cheaper to run than EVs. Who wouldn't want that? You'd be surprised to learn that the engine in question isn't completely new. No, it's actually a derivative of Toyota's fantastic 1.6-liter turbocharged three-cylinder, which has been celebrated worldwide by petrol heads for its extremely high power output, enjoyable sound, and outstanding reliability. This makes it an ideal starting point for developing hydrogen-powered internal combustion engine. The engine operates similarly to a typical internal combustion engine that uses LPG as fuel. Hydrogen is a gas, not a liquid, and requires an extremely robust and virtually bulletproof tank for storage to prevent escape, as it is highly flammable. Additionally, since hydrogen isn't in liquid form, the engine needed completely reworked fuel injectors designed for gas rather than liquid. Along with the injectors, Toyota has also incorporated considerably hardened valves and valve seats, as well as much stronger connecting rods that can withstand the cylinder pressure necessary for hydrogen. This resulted in an engine that could withstand continuous torture without breaking down, and was as reliable as its more conventional counterpart. So, in essence, it was bulletproof. Hey, what did you expect? We're talking about Toyota here. To make matters even better, Toyota has also announced the development of even more hydrogen-powered internal combustion engines. The most notable of these will be a naturally aspirated 5.0 V8, which will be used as a workhorse engine in trucks, SUVs, and, when tweaked and finely tuned, even sports cars. Its projected power output will be over 450 horsepower. Oh, and the cherry on top is that this engine will be developed in collaboration with Yamaha, just like the fabulous 2JZ from the old Supra, and that beastly 4.8 V10 found in the Lexus LFA. We're pretty darn sure the upcoming V8 will be a black. We can't wait to see these engines being utilized in real life, which leads us to the next question. When will these engines get officially adopted? Well, they are technically already adopted, at least the 1.6 one. Toyota fitted the engine to a Yaris GR and even a Corolla Cross as soon as it was developed. These cars are called the Toyota Yaris GR H2 and the Toyota Corolla Cross H2. Oh, and don't worry, these cars aren't gutless, as the reworked engine managed to put out similar levels of power and torque as the petrol-powered cousin, making these cars actually daily usable and fun. To add to the fun factor, the noise coming from the back is also fabulous, as the car sounds just as good as the petrol-powered alternative. Can't wait to hear what a low-revving torque monster of a V8 will do. Speaking of which, the V8 is expected to be fully developed in about a year, which means that we'll be hearing, unintended, about it very soon. Granted, the previously mentioned cars are just prototypes that won't see any real use. However, the creme de la creme is that Toyota projects that fully functional hydrogen combustion vehicles will hit the market by the end of the decade. Honestly, we're absolutely thrilled that EVs are finally getting a true competitor in terms of green energy and overall efficiency. We cannot emphasize enough how pleased we are that internal combustion engines aren't going the way of the dodo just yet. We're eager to start seeing and hearing them on the streets. That is, if we ever get the chance. You see, the Inline 3 and the V8 began development during Akio Toyota's tenure, who was keen on keeping internal combustion engines as the primary way of powering vehicles. Koji Sato is, unlike his predecessor, much more focused on developing EVs, as he believes they offer numerous benefits over traditional internal combustion engines. In fact, he's so committed to modernizing Toyota that he announced the company will introduce over 10 completely new EV models by 2030, which is music to our ears, especially considering their extremely late start. Granted, the man isn't giving up on hydrogen as a power source. However, there are a couple of issues that need to be addressed regarding hydrogen-powered internal combustion engines, and the first is their efficiency, or rather, their inefficiency. Hydrogen engines are much thirstier than their petrol-powered counterparts, and aside from being greener, they typically offer far less power. The 1.6 hydrogen-powered inline 3 is as powerful as its conventional twin, yet it consumes fuel much faster, so it must be equally powerful. By making them economical, we'd make hydrogen engines utterly gutless, which, let's be honest, nobody wants. On the other hand, as reliable as the inline 3 is, and it is reliable, It remains a complex mechanical assembly with numerous components that could easily break down and significantly impact its reliability. This means maintenance will be quite expensive, notably more so than for hydrogen fuel cell EVs like the Toyota Mirai. Additionally, FCEVs provide a much larger range than hydrogen internal combustion engine vehicles and are similarly quick to recharge, making them a more rational option than the admittedly much cooler internal combustion powered vehicles. Oh, and even though hydrogen is plentiful, it still needs to be converted for regular use, which requires a lot of energy. Because it is extremely hard to convert, there will be many conversion losses, making hydrogen dirty to produce. Storing hydrogen is also extremely challenging. Not only is hydrogen flammable, but it can also be explosive under certain conditions, making it particularly finicky to store. It tends to leak due to its small molecular size, which is why armored tanks are necessary to keep it as safe as possible. Unfortunately, storing hydrogen in vehicles is just one of its problems. Storing it outside the vehicle presents an even bigger challenge. It requires constant cooling, monitoring, and careful handling, resulting in significant inefficiencies in the long run. To save yourself the hassle, simply go and buy an EV, at least for now. They are quicker, more common, and because of their popularity, considerably more convenient to charge. Yes, we know lithium-ion batteries are also prone to catching fire, and mining them is dirty for the environment. However, they're still far greener than hydrogen because they're much more developed than hydrogen-powered vehicles, both FCEVs and hydrogen combustion ones. That doesn't mean you should give up on hydrogen, though. No, hydrogen is definitely the way of the future. It just needs a lot of refining before it becomes a viable choice for regular users. That's why companies like Toyota and BMW continue to nurture the technology, even though it's completely unprofitable. The relationship between electric vehicles and hydrogen-powered vehicles is essentially the same as that between traditional vehicles and electric vehicles a couple of decades ago. Overall, we genuinely believe that hydrogen is the future. However, we regret to announce that we are not yet in the age of hydrogen vehicles. Until we address these significant issues and inconveniences, we will need to move away from hydrogen combustion vehicles. However, we are in the age of EVs, and we're pleased that the entire industry is looking for an alternative to lithium to create a more environmentally friendly battery. Believe it or not, Toyota is actually leading the charge with its all-new battery type, which doesn't use lithium or any other rare element at all.
Okay, well, this one, again, as we watched how these hydrogen
At the center of this big structure,
how the hydrogen
I believe that
combustion engine can be an alternative choice for the vehicles, and this one, well, as it says, is released in 3 months ago, but this news about the Toyota and working on the hydrogen, it's been years. Now we like to see how it goes, but they are saying that it's very promising and led by the Toyota. As mentioned here, one of the reasons why the Toyota is working on this hydrogen combustion engine is that the Toyota is kind of a slow adopter of the electric vehicles. It's much slower than other companies. So they were working on this hydrogen combustion engine as an alternative. So we can see that a lot of companies have a different background, different direction, but the point is that all they are making the same types of effort, moving toward the what would be the most ideal, most economical, mostly eco-friendly and transportation system. So they do a lot of research. They and all engineers are working together and put all their energies with very ambitious motivations. So we are certainly part of them, working together, not just inside Korea, but as a global, the movement. If you are interested in the fuel cell, I mean, Toyota hydrogen combustion engines and working on that, well, why don't you apply the Toyota in Japan or global locations. So I like to emphasize that these all kinds of effort is not inside one company, not in one side the country. It's a global trend. So I hope that you can contribute to this effort, and as a return, you will be a very can play a very important role in this society, and then that's how engineer need to do. Okay, well, this is the all topics I like to cover today. Again, the review of the fuel cell and review of the hydrogen combustion engines, and I hope that you got some new motivation at least. Okay, again, if you have any further questions, and share with together through a Kato, and also last week I didn't assign you any homework, considering all the holidays. But this week I will assign you some homework, and then I would like to quickly go through all the chapters we plan to do. Basically, we're not gonna cover all the chapters listed in this overview, but you can get the most important idea. And next one, as you can see that the hydrogen in land mobility, well, rather than just the passenger vehicle, there will be a trained hydrogen train and hydrogen trucks and buses, and the infrastructure. Infrastructure is the fuel system. This is the much needed, and the and also hydrogen for air and sea mobility. And you can develop, you can contribute to these types of industry where they need to apply the hydrogen for air and mobility. And speaking of this, one of the key application is the eVTOL or UAV, led by the Hyundai. Hyundai, their future product they are investing right now is the eVTOL. They call it AAV, and also secondly, they are working on the humanoid. Okay, I would like to close this. Let's see. AAP and Hyundai Motor Group. Hyundai Motor Groups, they are introducing the advanced humanoid, and the reason I like to emphasize this humanoid is that the all humanoid and needs also energy power system as a unit of energy storage inside, and then I'm sure that there will be some battery. So the half of the this total system can be a battery, and the sort of a lot of motor in there. So that can be also you can think of many different types of energy storage, even hydrogen, electricity can be thought, and the There are lots of oops. Well, simply says it's a flying car, and very soon this flying car or AAM, advanced air mobility, we call AAM, will be commercialized very soon. Basically, all the technology has been already developed, but a lot of regulations and laws have to be adjusted. Now we engineer already developed. So Hyundai has put a lot of effort to develop this AAV and also humanoid. Either this and also hydrogen vehicle, fuel cell vehicle. So fuel cell vehicles and the AAV and humanoid. These are three items which Hyundai is putting and developing. So we need to understand and let's see how can we contribute. Well, doesn't need to go to join the Hyundai, but it's good to understand what's going on in the Hyundai. And the okay, well, this is just the reminder of activities. Okay, so see you next week, and then I will assign a little bit about the homework related to covering all the subject we have covered so far. Okay, thank you, and then see you next week.